Hello everyone. Today we are going to solve a numerical problem on the point form of Ampere's circuitry law from the electromagnetic fields course. So here there is a problem given H bar. H bar is the magnetic field intensity due to a current source. Is given by H bar is equal to y cos alpha x with unit vector Ax plus y plus e to the power of x Az. So here you need to describe the current density over the yz plane. So before solving this problem, you need to clearly understand that in the question it is specifically mentioned that it is over the yz plane. It means that a hint is given. Like when it is on the yz plane. So here x will become 0. So this is what the first thing you need to remember from this problem. Okay, and other one is you need to find out the current density. And as per the point form of Ampere's circuit law, so we know that the curl of h bar is equal to j. So if you are finding this curl of h bar, then you will be getting the j bar. So that's what in the question it is being asked, like to find out the current density over yz plane. So here current density directly you will be getting through the curl of h bar, and the data is also given with respect to the h bar. So simply you need to do is you need to find out the curl of h bar. So finally you will be getting, so this j bar. And one thing you need to remember this is here it is given as y z plane, and also in the unit vectors if you see with respect to the h bar there is ax bar and the az bar. So it clearly indicates that this is in the rectangular coordinate system. So let us solve this solution. So let's find out the solution for this. So first of all, in order to find out the curl, so we need to find out the determinant of this h bar. So here we can able to write it in the matrix form. So I'll be writing the unit vectors ay, ax, ay and az. Okay, and with respect to this del, so it is dou by dou x, dou by dou y and dou by dou z, because we know that the del operator can be written as dou by dou x into ax, okay, dou by dou y of ay, dou by dou z of az, whereas ax, ay and az are the unit vectors in those specific directions, x, y, z directions. Okay, and in the h bar it is given that if you clearly observe in the question, you can able to see the component with respect to the ax, you can able to see the component with respect to the az, but with respect to the ay, so the parameter is missing. So no need to worry, you can able to put that parameter as 0, because as ay a component is not present, you can able to put it as 0. And what is the component of ax? Ax component is y cos alpha x ax. Okay, so the same thing I am writing here. So y cos of alpha x. So this is the component of ax. In the same way for az, so it is given as y plus e power x. Y plus e power x. You can able to see here from the question, y plus e power x is the component of ax, az bar. Now you need to find out the determinant of this. Then you can able to get the current density. Then how to find out this determinant? So for the in the first case, you will be getting a three values with respect to the ax, right, plus you will be getting some component with respect to the ay, and you will be getting some component with respect to the az, because whenever you are doing a cross product, you will be getting a vector. The vector is nothing but the current density, so which you are going to find out for it. So let us find out how we can able to get the components of ax with respect to the ay and with respect to the az. So many of the times we have solved, but however we will be solving in order to find out the first one. So remove this and multiply this with this and these two. Okay, so when you are multiplying this, you will be getting, so dou by dou y into this y plus e power x, y plus e power x minus 0 into this. So minus 0 into whatever it may be, it will become 0. Okay, so we got this component. Now what I am doing is now remove this part. Okay, and now you can able to multiply this with respect to this component and this with respect to this component. But here you can able to observe that as we are doing in this order, so this you need to replace always this minus, because you're not multiplying this with respect to this, but you're doing with this component. Okay, we're multiplying this with respect to the az component. Actually it should be x to y, y to z, z to a, but when you are doing here, you are doing from x to z. Okay, see here, this into this, x component with z component, x component with z component. So better you can able to put it here minus. Okay, and see, so what I can able to write here, so dou by dou x, dou by dou x. Okay, so this component into this y plus e power x. Okay, and this into this minus. Okay, so dou by dou x of, sorry, dou by dou z of y cos alpha x. Here I am writing because there is a no space is not sufficient. It's okay, you can hope you can able to understand this one, right? And in the third component, what I am doing is, now I am removing this. Okay, and now I'm multiplying this component with respect to this and this with respect to this. So dou by dou x into 0 is 0, minus dou by dou y into y cos alpha x. Okay, dou by dou y into y cos alpha x, y cos alpha x. However, I am going little bit fast in this doing this cross product, because many times in our previous lectures we have seen how to do the cross product, and hope so directly I am substituting the values, and let us see what after removing these zeros and all. So I am writing the direct step something like this. So it will become dou by dou y plus e power x of ax bar. Okay, so what I have done is I have simply removed this zero. That's it. This zero I have removed. I am writing so that to make this equation very simple. Next, minus, and if you check here, minus dou by dou y. This will be as it is, dou by dou x, dou by dou x, y plus e power x, y plus e power x, minus dou by dou z, y cos alpha x, y cos alpha x into ay. Here I am, so don't forget to write the unit vectors into ay, plus the third component. The third component is, here is 0. We can, after removing this 0, you will be getting, so minus dou by dou y of y cos of alpha x to az. Okay, now what you need to do, you need to do the partial derivative of this one with respect to dy. You need to do the partial derivative of y plus e power x with respect to the dx, and in the same way with respect to the dz here and with respect to the dy. So let us see how it can be done here. So dou by dou y, because as there are two components, this is one and this is one, and this is with respect to x, so this will become 0, because whenever we are doing partial derivative with respect to the y, so this will become 0 because there is no y component here, and this will become 1. Okay, so simply 1 into ax unit vector minus, and here if you see this again there is a y and there is e power x. So partial derivative of y with respect to dx will become 0, and partial derivative of ex will become e to the power of x itself. Okay, minus, and if you see here, there is no z component out of this equation, y cos alpha x. There is no z component of, there is no z component, and here we are doing partial derivative with respect to this z. So then this will become 0, right, into ay bar plus, we can able to put it minus, because here minus, if you take out it will be minus, and dou by dou y cos alpha x. This is where you need to be very concentrated about, because so dou by dou y of y, it will simply become 1, right, it will become 1, and finally only this parameter will be remaining as it is, cos alpha x, cos alpha x into z. Hope you understood here. So dou by dou y of, okay, partial derivative of y with respect to y will become 1, and this component is a constant here, because here only we are doing with respect to the y. So this constant will be as it is, and this y will become 1 because we are doing the partial derivative of this component. Okay. Now in simple steps, we can able to write it as ax bar minus e power x ay bar, okay, minus cos alpha x az bar. So this is the final equation which we got for the current density. But one thing we should not forget that here in the question is hint is given like it is kept on the yz plane. It means that x is equal to 0. So finally you need to substitute wherever you find x, try to substitute with 0. So this equation now it will becomes, so ax bar minus, so e power 0 because x is equal to 0, so minus e power 0 into ay, e power 0, e power 0 into ay bar, okay. So next minus cos alpha into 0, minus cos alpha into 0, finally into az. So what is cos 0? Cos 0 will become 1. So this equation will become ax bar minus e power 0 will become 1. So it is ay bar minus cos 0 is equal to 1. So it will become az bar. So this is curl of h bar. So ultimately what you will be getting, curl of h bar is nothing but the current density. So here you can able to understand that whenever the h bar, the magnetic field intensity is given, and if you are asked to find out the current density, simply do the curl of h bar, then you will be getting the value of j, okay. And don't try to forget that in which plane it is lying, okay. Suppose if you see here, so we are asked to find out the current density over the yz plane. So you need to understand that whether the other components are 0, because whenever a plane is perpendicular to the other axis, so here it means that in that particular plane, so there will be the other component will become so 0, okay. So this is how you can able to find out the curl of h bar, so that you can able to find out the current density over any plane. So thank you. We'll meet with some more number of numerical problems in the next class. So thank you.